Related rates problem number 25. Gravel is being dumped from a conveyor belt at a rate of 30 cubic feet per minute, and its coarseness is such that it forms a pile in the shape of a cone whose base diameter and height are always equal. How fast is the height of the pile increasing when the pile is 10 feet high?
So let's start with what we know. We know that the volume of a cone is V equals 1/3 pi r squared times the height. We also know that the rate at which the volume of the cone is increasing, or dV over dt, equals 30 cubic feet per minute. We know this because the problem tells us that gravel is being dumped into the cone at a rate of 30 cubic feet per minute. The problem also tells us that the diameter of the base of the cone is always equal to the height of the cone, which is why we get the formula 2 times the radius equals the height.
So the problem is asking us to find the rate at which the height of the cone is increasing when the height is 10 feet high, also known as dH over dt when h equals 10. What do you think the answer is, Riley?
So let's start with the equation for the volume of a cone. Notice how in the second line substitute r squared with 1/2 h squared. We can do this because we already learned that 2r equals h, so 1/2 h must equal r. In the third step, we just simplified a little more by changing 1/3 pi to pi over 3 and distributing the squared symbol for 1/2 h squared and making it h squared over 4. We then further simplified by changing h squared over 4 into h cubed over 4. Finally, we just multiplied the fractions together to get h cubed pi over 12. Now comes the tough part of finding the derivative.
The derivative of the left side of the equation, v, is simply dv over dt. Now we have to find the derivative of the right side. Pi over 12 is just actually a coefficient, so we can move it to the outside. Now we need the power rule and chain rule to find the derivative of h cubed. First, we will use the power rule on the outside, bringing the 3 down and changing the exponent to a 2. Now you can't forget to multiply the derivative of the inside, which is dH over dt. Next, we drag the 3 coefficient to the rest of the coefficients on the outside to make 3 pi over 12. We then simplify this to 1/4 times pi h squared times dH over dt. Do not be confused by our written work. Pi h squared is not part of the denominator.
Now it's time to plug in some numbers. For starters, if you recall from earlier, dV over dt equals 30 cubic feet per minute, so we'll just plug that in now. We also know that we're looking for dV dt at h equals 10, so we'll plug in 10 for h as well. We end up with the equation 30 equals 100 pi over 4 times dH over dt. As you can see, 100 pi over 4 easily simplifies into 25 pi. Now remember, the main goal of this problem is to find dH over dt, so to do that we'll have to get dH over dt by itself. That means we have to divide 30 by 25 pi. This is easily simplified as well, being equivalent to 6 over 5 pi. So now we finally have our answer. The height of the cone, or the pile of gravel, is increasing at a rate of 6 over 5 pi feet per minute when it's at the height of 10.
Yay! How does that answer sound to you, Riley?
Yeah!